Humans have used the power of falling water to help them do work for thousands of years. Water that is high in the air has gravitational potential energy. Potential means the possibility of something. In this case, the force of gravity could make the water fall from high in the air to somewhere lower. When the water falls, its potential energy is converted to kinetic or movement energy, and this can be captured and made to do work. Dams create large lakes that have a lot of potential energy. The higher up they are, the more potential energy they have. Tubes or chutes called penstocks or pentroughs can direct the falling water to water wheels, where the kinetic energy of the now fast-moving water can be captured. Your challenge today is to make a machine to capture the gravitational potential energy of 1 litre of water and turn it into useful work. We will measure this by seeing if you can make a winch lift up a 25-gram weight. The higher you can lift the weight, the better your design and the better your score. To do this activity, you will need a nice clear space to work, some scissors, a ruler, some spare plastic tubs or lids, and some rods to make a water wheel. You'll also need some glue or tape and some string. You will also need a container that can hold 1 litre of water to power your water wheel. If you have any tubes or pipes or perhaps a funnel, you may want to use those to help direct the water. It will get wet, so you will need a big bowl to capture all the water in, or try this outside or perhaps in a bathroom. To make your water wheel, you will need a rod to act as the axle and a container or box to hold it. You could use a recycled plastic tub with holes in. You will need to secure several paddles or buckets to your axle. These could be cut from old plastic tubs and bottles, or you may be able to use spoons or cups. You could do tests to find out what shapes, sizes and number of paddles work best. The fast-moving water should hit the paddles of the water wheel on one side, and the energy of the moving water will be transferred and the water wheel should turn. To make a really efficient design, you don't want any of the potential energy of the water to go to waste, so we'll want to make sure that as much of the water as possible hits the paddles or buckets of your water wheel at just the right speed. The water wheel will be moving quite fast, and you can control this with funnels or tubes if you want. Does the height of the reservoir make a difference? When you have a water wheel that's working, you'll need to think about the winch. Tie a string tightly to the axle on the other side of the water wheel. This should be about 1 metre long and hang down. The thickness of the axle can make a difference to how quickly it winds up, and you can wrap the string onto a bigger drum if you want. A big drum may make it harder to spin though, so do experiment. Tie a weight of 25 grams to the other end of the string. Test that weight is lifted easily when you turn the water wheel by hand. Do some tests with running water and make any improvements that you can to your design. When you are ready to test, carefully measure 1 litre of water into a container. That is your reservoir. This is the only amount of water you can use in the final test. Use a ruler marked in centimetres or a marked string to keep a record of how high the weight is lifted. You may need someone to help you do this. Remember to take your final measurement from where the bottom of your weight is, not the top. When you are ready, pour the water onto your water wheel or into any pipes or chutes you have made to make the wheel move. When the water runs out and the water wheel stops moving, make a note of how far up you lifted the weight. Be careful, the weight may fall back down when the water stops. You may want to do this testing a few times to make improvements. When you cannot improve it anymore, do a final test. The height in centimetres that you lift the weight using 1 litre of water is your score. There are lots of things you can experiment with in this activity. One thing you can do is choose the height that the water falls from. Scientists and engineers use equations to predict how things will work. Gravitational potential energy has this equation. The gravity is always the same here on Earth, so do you think gravitational potential energy will go up or down if you change the height of the same mass of water? That's something to think about.